Great. Welcome, everyone, to the NOAA Climate Stewards June webinar. Before we begin this evening's presentation, Turning Misinformation into Educational Opportunities, I have a few bookkeeping slides to go through for everyone. First of all, tonight's broadcast is being recorded. Links to a video archive are going to be distributed to everyone who's registered within a week. Now, if you don't receive a link to the archive, send me an email with the subject, Request Link, June 2017 Webinar. Now, a video archive of all the slides presented here this evening, both my information and education resources slides, as well as those presented by Dr. Cook and previous broadcasts going back to 2013, are available on the NOAA Climate Stewards Google website. If you can't access this site, you can send an automated access request through Google or just send an email to me, Bruce Moravchik, with the subject, Request Access to CSEP Google site. Everyone who participates in the entire presentation this evening will be receiving a certificate of attendance denoting their participation in 1 contact hour of professional development. And, as you know, if you've been with us before, all the attendees' microphones are going to be muted during the broadcast. If you'd like to ask a question, please type it into the question panel on your GoToWebinar control panel. And during tonight's broadcast, you'll receive an email with a link to a post-webinar poll. I promise we use all of the data we receive in these polls, so your prompt responses are important to us, and they do help us prepare for future events. Please check your email right after the webinar. Now, we'll be taking hiatus in July, as we do most years, but please stay tuned for Monday, August 7th at 7:30 p.m. is our next webinar, Transitioning States and Countries to 100% Clean Renewable Energy for All Purposes. Mark Jacobson, a professor of civil and environmental engineering from Stanford University, will be offering that presentation. And of course, don't forget professional development opportunities that are coming up through NOAA Climate Stewards and our partners this summer. In July, we'll be offering Resilience. It's not just surviving the zombie apocalypse. That's going to be in collaboration with Connecticut Sea Grant in Groton. Engaging Youth in STEM and Community Resilience. That's being done in collaboration with a number of partners in Fairbanks, Alaska. And in August, NOAA and the Made Clear Climate Education Academy will be taking place in Towson, Maryland, with some prior online presentations being done later this month. Now, if you'd like more information, please sign up to the NOAA Climate Stewards list. Now, we're going to be using a different list, a newer list, than we have been using for the past several years. Everyone who is currently on the list will be transferred over. We have been assured and we've seen that this new broadcast medium will be much easier for everyone to use and much cleaner. So we're really looking forward to seeing that. All right, and with no further ado, I would like to turn this over to Dr. Cook and provide the formal introduction.
Hang on a second. I've just okay.
No worries. Well, before Dr. Cook begins, John Cook, as I mentioned earlier, is a research assistant professor at the Center for Climate Change Communication at George Mason University, researching cognitive science. In 2007, he founded Skeptical Science, a website which won the 2011 Australian Museum Eureka Prize for the Advancement of Climate Change Knowledge and a 2016 Friend of the Planet Award from the National Centers for Science Education. John has co-authored the college textbooks Climate Change, Examining the Facts, with Weber State University professor Daniel Bedford, and was a co-author of the textbook Climate Change Science, A Modern Synthesis, as well as the book Climate Change Denial, Heads in the Sand. In 2013, he published a paper analyzing the scientific consensus on climate change that was highlighted by both President Obama and UK Prime Minister David Cameron. And in 2015, developed the massive open online course, or MOOC, at the University of Queensland on climate science denial, which has received over 25,000 enrollments. John earned his PhD in cognitive science at the University of Western Australia in 2016, and I am both honored and feel very fortunate that we are able to welcome him here this evening. Thank you very much. John, the floor is yours.
Thanks, Bruce, and thank you very much. Yeah, thanks very much for the invitation to talk. I really appreciate it. And so I really come from a background in communication and cognitive science, but over the years, as I've been engaging with the public in climate communication, I've been drawn more and more to just the potential and the power of education and research into that area. And so what I'm going to talk about today is really straddling both disciplines, cognitive psychology, the psychological research into communication and debunking and misinformation, but also educational research into addressing misinformation in the classroom. And what I found is that the two different disciplines coming at it from completely different angles, both are converging on very similar pictures. So now let me see what gets going. Okay, so I wanted to start by just talking a bit about the psychology of debunking and what research is on. When I started to learn about the psychology of debunking, I guess the first thing I learned was really how people think. What's going on under the hood when people believe something that is wrong, some misinformation, and then they find out that that misinformation is incorrect and they have to change their minds about something. And so what I learned is that the way people conceptualize the world is they build these mental models of how the world works. And mental models are made up of many different parts, and they're all interlocked. A causes B and B causes C. But what happens if B is wrong, if it's a piece of misinformation? And then when you debunk B, you're telling people that's wrong. Then they have to remove that piece of misinformation from their mental model. And that creates a gap. People don't like gaps in their mental models. They actually prefer a complete, inaccurate to an incomplete mental model that is more accurate. And so if you don't fill that gap with something else, then the myth comes back and it continues to influence people. And so psychologists call this the continued influence effect, and they've measured it in a number of experiments where they introduce some misinformation to people, they then correct it, and then even though people remember the correction and accept it, they still continue to be influenced by that initial misinformation. Unless something happens, unless as well as correcting the misinformation, you also replace it with a replacement fact. So you not only tell them that B is wrong, but you also give them something else to slot into their mental model that fits all the causal explanations and relationships that the original myth fit. A good example is they've done where they had in a psychology experiment where they had a suspect who was accused of a crime, and they would present a whole range of conclusive evidence that proved that the suspect was innocent, and yet people still thought that this person might be guilty. And they found that people only psychologically exonerated the suspect if they provided an alternative suspect as well as the evidence that he was innocent. You need to replace the myth with a replacement fact. And so if I could sum up all of the research, psychological research into debunking, I would summarize it as fight sticky myths with stickier facts. We have to replace the myths with facts, but we also need to make the facts as compelling, as simple, as sticky as possible. By sticky, I mean it grabs people's attention and it stays in their memory. How do we make our messages, our science, sticky? A useful framework that I've found comes from a book called Made to Stick by the Heath brothers, and I've been using this framework for years now with my climate communication. What they found in this book was that sticky messages that go viral or that achieve public consciousness, share some of the 6 following characteristics. They're always simple. They often take people by surprise. They're unexpected. They need to come from credible sources. They need to be concrete rather than abstract. Emotional messages are more likely to be shared and remembered. And the way that people remember information is in the form of stories. So if you can communicate messages telling the story, then it's more likely to be remembered and to be shared. And so, so I'm going to give an example of a sticky fact replacing a sticky myth. But before I do, I was just interested in what are the most common myths that you might have encountered. So I've never done this before, but apparently you can, this webinar system allows you to fill out a survey, and you can choose from, I've just chosen 5 of the most common climate myths that are around. I'll be interested in what are the ones that you've encountered the most often.
Hey everyone, this is Bruce. So please click on your answer on the screen. We'll give just about a minute for you to do so, and then we'll stop it and we'll reveal what everyone has selected. Great, we've got about 85% of our attendees voting. We'll just...
Oh wow, that's pretty good.
Yeah, we'll just leave it up for another moment or so, and then we'll close it. So make your final decisions.
I'm hanging on tenterhooks here. I can't wait to see the results.
Okay, that looks good. So let's close it up. And here are the results.
Right. It's funny. I wrote a book, or co-authored a book with Hayden Washington a number of years ago. It was called Climate Change Denial. And when we did a number of different radio interviews traveling around in Australia, Sydney and Canberra, and we would often have listener call-ins asking us questions, and every time there was someone that would call in and ask that exact one, the climate's changed in the past, so it must be natural now question. And then our very last interview of our trip, we were having a bet on what it would be, and the first caller was just said, "I'm a geologist," and and then started talking about past climate change. So yeah, it's a very common one. And if we get time, we can always have a look at it later on in the presentation. But if we could jump back to the slideshow, there's one in particular which is very recent. And this is actually from Friday. So on Thursday, President Trump pulled America out of the Paris Agreement. And on Friday, Scott Pruitt went into the White House briefing room, answered questions about that. And during the question and answer, the Q&A, he said we're actually been in a hiatus since the late 1990s. So he was arguing that global warming hasn't been happening. And this is a common claim, denialist claim. It's been around for the last decade or so. And how do you respond to that? Normally scientists will respond by talking about statistically significant trends and confidence intervals and long-term versus short-term trends. And these are very appropriate scientific ways to address whether there's a global warming trend or not. But at Skeptical Science, my website, we played around with different ways to communicate the fact. And we ended up coming up with an analogy which we thought was quite a sticky way to communicate the fact that global warming has still been happening unabated since the late 1990s. And that was the fact that when you look at all the heat that's building up in our climate system, the total amount of heat, with most of it going in the oceans, is building up at a rate of 4 atomic bombs every second. So the greenhouse effect is still blazing away. The laws of physics didn't change in the late 1990s. Global warming is still happening. And we found that this analogy ticks almost all of the sticky boxes, the 6 traits of sticky messages. It's quite a powerful way to try to address the myth that there's been a hiatus in global warming. So that's I guess the first section of my talk was just the general principles of debunking misinformation. And communicating our science in a sticky way is crucially important. It's only half of the story when it comes to addressing misinformation. And to illustrate that, I want to show you some results from an experiment that was run by scientists here at George Mason University, where I'm based now. This experiment was done long before I got here. And what they did was they presented different types of information to the participants in their experiment. The bar on the left was a group where they just presented facts about climate change, or basically communicating the fact that there's 97% consensus among climate scientists that humans are causing global warming. And they found that when you present the facts, it has a strong positive effect. Facts work. The second bar shows what happens when you present people with just misinformation. And they found that lowers people's acceptance of climate change. Misinformation does have a real negative effect. Now the third column is the real important one. This is what happens when people were presented with both types of information, fact and misinformation. And they found that the two cancel each other out, that there was no statistically significant effect. And this is really important from a communication and an education point of view, because it means that even if we get our communication right, like get it, fine-tune it and it's perfect, we explain it well, it's sticky science, even our sticky science can be wiped out by misinformation. So what do we do about that? There's a great tweet by a Russian chess master, Kasparov, that really sums up the real dilemma here, the key problem about misinformation. That misinformation doesn't misinform people, it doesn't just have them believing wrong things. One of the more dangerous influences of misinformation is it stops people believing in facts. It annihilates truth. And it's a bit like in those old Star Trek episodes where Captain Kirk gets cloned and there's an evil Captain Kirk clone, and Spock's trying to figure out which is the real Kirk and which is the fake Kirk. What we need to do as communicators and educators is help people resolve that conflict, help them be able to tell the difference between facts and misinformation. We need to provide a tiebreaker, essentially. And the way to do that is through inoculation theory. So in this experiment, well, hang on, let me explain what I mean by inoculation theory. So this is a branch of psychological research that takes the concept of vaccination and applies it to knowledge. So with vaccination, what happens is you get exposed to a weak form of a virus that builds up your immunity, your resistance, and then when you encounter the real virus, you don't get infected. Now, in knowledge, psychology researchers have found that when you expose people to a weak form of misinformation, that builds up their immunity to misinformation so that when they encounter the real misinformation, they're no longer influenced by it. So what do I mean by a weak form of misinformation? Basically, inoculating text has two things. Firstly, it contains a warning of the threat, that people are going to be misled by misinformation. And secondly, it includes counter-arguments explaining how the misinformation misleads people. And so, in the experiments that was run at George Mason University, the misinformation they used was verbatim text from a website called the Global Warming Petition Project. And this is a website that has a petition of over 31,000 signatories, people with a science degree. And they've signed a statement saying that humans aren't disrupting climate. And the purpose of this website, the purpose of this petition, is to convince people that there's no scientific consensus that humans are causing global warming. I don't know how many of you are familiar with the petition project, but there's I've got a survey here that, that lists 5 different possible things that could be wrong about the petition project. So Bruce, if you could bring up the survey, and whether you're familiar with it or not, I would be interested in you all having a guess on what you think is the key, I guess, fundamental.
Great, so we've opened the polling. We're just going to take about a minute or so for everyone to vote. Just want to confirm, John, that you're still on the line because it seems that we may have lost you. Okay, I'm not hearing you, John. But the polling is still open. Okay, we've got about 73 or 4% of the people voting. Let's see if we can close it up in the next 20 seconds or so. And John, we seem to have lost your mic. Okay, so I'm going to close the poll up now with about 85% of the folks voting. Very good. And here are the results. Hopefully, John, can you hear me now?
Yes.
Okay, very good. You're back. Good. So here are the results that we have.
Okay, all right. So that's really interesting. And firstly, all 5 of those points are true. They are, like, all of those accurate. But it's really kind of a matter of debate over what is the key thing that is wrong with like what is the key flaw of the global warming petition project. And I think I'll demonstrate that by showing the inoculating text. So I'll go back to the slideshow. Now, in the experiment that George Mason and the other scientists were performing, I should mention that the lead author was Van der Linden. And let's see if I can get this working. So here is an excerpt from the inoculating text that they showed people before the misinformation. And it included several things that were wrong with the petition, or way to misled people. That it included people like the Spice Girls, from Star Wars, that 31,000 is a big number, but it's only 0.3% of people with a US science degree, and only a fraction of the signatories were climate scientists, like 0.1%. And so yeah, they went with 3 different counter-arguments in their inoculation. And what they found when they presented the misinformation after an inoculation was that the misinformation was mostly neutralized, that the facts were finally allowed to have a positive effect again. And so the fact that misinformation can cancel out the effect of scientific information, but if we inoculate people, then it neutralizes the misinformation. Now, at the same time that these US scientists were doing their research, I was at the University of Queensland in Australia, and unbeknownst to me, not knowing that any of this research was going on, I was conducting a very similar experiment myself independently. And I was actually using the same misinformation, the Global Warming Petition Project. And I found that when I presented misinformation by itself to people, just as the same as the US experiment, it lowered people's climate acceptance. And this graph here shows how their perceived consensus went down. And the horizontal axis in this graph is political ideology. So as people were conservative, they were more influenced by the misinformation, and a bigger effect in lowering their acceptance of climate change. Now, I also showed the people, or some of the participants in my experiment, some inoculation text before I showed them the misinformation. But my inoculation was a bit different to the US experiment. What I did was, firstly, I didn't mention the Global Warming Petition Project at all. What I did instead was I explained the technique of fake experts and used the analogy of tobacco as a way of illustrating this technique. Fake experts being people who convey the impression of expertise but not actually possessing any relevant expertise. And so what I found by explaining the technique of fake experts was, again, this completely neutralized the misinformation. The misinformation had no statistically significant effect on people's climate attitudes. And so both show that it's possible to inoculate people against misinformation to reduce its influence. And so let's go back to that myth that I introduced a little earlier. Scott Pruitt arguing that global warming had stopped over the last few decades, and showing you that sticky side. There's actually been global warming at a rate of 4 atomic bombs per second. But you have the fact, you have the myth, you have these two conflicting pieces of information. How do you reconcile the two? How do you break the tie? How do you help people to discern fact from misinformation? And one way to do that is just to explain the technique of cherry picking, the idea that people can paint a misleading picture by just looking at a small even when you have a long warming trend, it's possible to choose any short period in the long-term warming trend. Global temperatures seem to have stopped. And you can do that because the global temperature is jumping up and down. So by cherry picking, you can paint
For everyone on the line, we're aware that we've lost the sound for Dr. Cook. John, if you can hear me, we've lost you at the beginning of the cherry picking slide. If it's possible for you to dial in on the phone or to reboot, that would be helpful at this time. If need be, I can forward your slides. Thanks for your patience, everyone. We do have these technical errors from time to time. But the message that Dr. Cook was presenting from the slide seems pretty clear how folks can cherry pick from the data from different segments to make it appear as though climate change is not occurring during specific periods. So John, you're still not, we still can't hear you. If it's possible for you to dial in, that would be helpful. Thanks for your patience, everyone. Hopefully this won't be very much longer. Well, in the meantime, while hopefully we're getting John back on the line, and I'll leave that line open for you. Just as a note to folks, we do have some additional resources for you to check out. These are, the first three are actually recent articles that were recommended by Dr. Cook for having a look at prior to coming to this webinar. If you have an opportunity, I think that you'll find that these are really quite interesting, and particularly the short inoculations have been taken, as you can see, from skepticalscience.com. And in fact, this debunking handbook, a guide to debunking misinformation, is one of the an earlier piece of research that Dr. Cook had put together. Also, very recently, an article has come out from the Yale University Climate Change Communication group about inoculating the public against misinformation as well. So this has become a very recent and popular trend in communicating with folks. I'd also like to draw people to the Psychology of Climate Change Communication, an excellent publication for folks to check out. And further, the National Center for Science Education, for those of you who are not aware, has some stellar resources, both for the teaching of climate change as well as the teaching of evolution in the classroom. And let's see. I see. John, are you back on the line now? I see. It looks like he's trying to log in. So we'll wait just another moment, and hopefully we'll get him back.
Can you hear me now, Bruce?
Yes, I can. Very good. So
apologies for that. My internet just went down, and I don't know. It's choosing a very bad time to get all patchy on me.
Okay, so you'll just need to we'll just need you to make yourself the presenter again. Very good. Much thanks to everyone for sticking with us.
Yes, my apologies for the interruption.
Yeah, and actually, John, can you begin again at your slide, which refers to the cherry picking of the data after you showed your slide of Scott Pruitt? Yes, thank you.
Sure. Okay, so as I explained, just explaining the science is not sufficient, because we now know that misinformation can cancel out sticky science. So you also need to explain the techniques that the myth uses to distort the science. And in the case of Scott Pruitt's hiatus argument, he's using the technique of cherry picking. And this is this animated graph illustrates this quite elegantly. It shows that when you have a long-term warming trend, it's possible to find any short period in the long-term warming trend where the temperature seems to be flat for a decade or two. And that's because temperature jumps up and down. There's a lot of internal variability. But when you cherry pick and only look at a short-term trend, it's painting a misleading picture compared to what you get when you step back and look at all the data. So pulling all this, all the psychological research together, I summarize it with this one slide, which is really the best practices structure for debunking misinformation. And first and foremost, you need to put the emphasis on the facts, and you need to make the facts as sticky as possible. You do need to mention the myth, but before you mention it, warn people that you're going to, so that they're cognitively on guard and less likely to be influenced by the misinformation. And having introduced these two conflicting pieces of information, fact and myth, then you need to resolve the conflict by explaining the technique that the myth uses. Here's an example of how not to do it. Like this is a debunking billboard on a bus stop, and it just has in huge words the myth that they're looking to debunk. So if you're walking past or driving past, all you will see is this myth, and then in very tiny writing underneath, it explains the facts and how that myth is wrong. But it puts the emphasis on the myth. And most debunkings do this. They use the myth as a headline, or they lead with the myth rather than the facts. And then that risks reinforcing the myth. So how do you explain the techniques of denial? The techniques that misinformation use to distort the science? I found that a really useful framework for this comes from a paper by Diet Helm and McKee in 2009, and they originally took this idea from Google, and they list 5 characteristics or traits or techniques that whether it's on climate change or tobacco causing health problems or vaccination or evolution. You see these 5 techniques summarized with the acronym FLIC, and then there are sub characteristics as well. So under logical fallacies, there's a range of other different types of logical fallacies. So let's test this framework. I've got a third survey. This is our last survey, and it's actually harder than you think sometimes, trying to identify the fallacy that a myth uses. And so I thought I would just one of the most common myths about climate change, and blaming it on the sun rather than on human activities. And I'd be interested in seeing what fallacy you think that this myth uses. What's the technique that it uses to distort the science? I was listening to or watching a YouTube video today of Oliver reacting to the President Trump taking us out of the Paris Accords, and actually in part of the video, he quoted a politician called Congressman, and the congressman actually used this argument, arguing that the sun was causing global warming. So it's an argument that still comes up to this day. So do we have our results in, Bruce? Okay, logical fallacies. Interesting. So this is the kind of the flaw in the system. I would love to actually talk to the attendees and hear more from them about what fallacies they think they were, and maybe towards the, if we have time at the Q&A at the end, we could perhaps have them explain what fallacy they thought it was when they chatted. And this is the thing, like with misinformation, often there isn't one fallacy, often there are a number of them. And the Global Warming Petition Project uses both fake experts and the magnified minority. And so it's possible that this myth does use multiple techniques. So we'll come back to that later, but if we could go back to the slides, Chris, because I think I'm running out of time. I'll quickly give an example of using that fact, myth, fallacy template. Sometimes when my research hacked in newspapers, like
Sorry, John, we've lost your audio again. Sorry,
is, I structure my response in
John, your audio is breaking up quite a bit. I don't know if it's possible for you to consider dialing in on the external line and still show your slides just for the audio's sake. But yeah, your audio is breaking up quite a bit. Or if you prefer, I can show you.
Okay. Your audio is breaking up as well for me.
Okay. Well, let's if you can go back to the end of your previous slide and just mention that, I think we'll be okay. Let's see how it goes.
Sorry, you broke up then, so I didn't hear your answer.
Sorry, John. Yeah, if it's, I don't know if it's, yeah, we're having some difficulties this evening, so maybe you can show from your last slide.
So,
okay.
Did you want me to?
Yeah, if we can begin from here, that'd be fine.
Okay, let's hope this works. So, so this was a right of reply that I published in a newspaper that had attacked my own research. And so in my right of reply, I structured it using the fact, myth, fallacy structure. And so in section here shows me the key facts that I wanted to communicate in my response. In establishing the facts, then I addressed one piece of misinformation in the article that I was responding to. So even though I was responding to an article that attacked me, most of my response was communicating the facts. And then the blue section here is explaining the technique that the misinformation uses. So I was using fact, myth, fallacy to not only communicate science, but also inoculate people against the technique of misinformation. So now I get on to my third section of my talk, which is about educational research into how to address misinformation in the classroom. Now, I first encountered this when I discovered a paper from 2010 written by Daniel Bedford, who's a professor at Weber State University in Utah. And he teaches his climate change class, college class, by information misconceptions about climate change. And he found that it was a really powerful way of teaching climate science. And so I started corresponding with Daniel and exploring the teaching technique he used. And we decided to write a paper about this teaching technique. He calls it agnotology-based learning. And as we wrote this paper, we discovered that there's a rich body of research into this teaching technique. And it's also called misconception-based learning. It's called refutational teaching. There's a number of labels, but in all of them, what it's about is teaching the science by addressing misconceptions about that science. And what this research has found is that when you address misconceptions about science, you get larger learning gains, and learning gains last life. Well, so they're bigger and longer. The learning gains fade less over time. There's also research from Derek Moore from the University of Sydney, and he teaches physics. And what he found was when he addressed misconceptions about physics, he also got much larger learning gains, significantly larger. And what's really interesting in his research was he also asked the students how confident they were about their understanding of the physics. And he found that the people who had the misconception-based learning actually had lower confidence but a better understanding. And so the people who were taught just straight science had a higher confidence that they were right, but they actually understood it much less. And so it's misconception-based learning actually pushes students up that Dunning-Kruger curve. They learn enough knowledge or understanding to realize, I guess, how much more they need to know. And there's a paper in 2010 by Christine Tippett that summarizes all the research into refutational teaching or misconception-based learning. And Tippett laments the fact that there's so few resources for educators that use this approach of misconception-based learning, and that there really needs to be more resources so that teachers can take this approach into the classroom. And so that's what we've been doing, is developing resources for educators. We started by developing a massive open online course on climate science denial, and this is a 6 course, the whole story of climate change. One week is on the reality of climate change, the next week is on that humans are causing it, the next we look at impacts, and then we go into climate models and past climate change. And with each lecture, each lecture is like a short 7-minute video, but we structure it using that same fact, myth, fallacy format. So we teach a key fact about climate change, then we introduce them to a myth that is related to that fact, and then we resolve the conflict by explaining the fallacy or the technique that the myth uses to distort the science. And we do this around 50 times. Like we look at 50 of the most common myths about climate change, and it's like 50 different flu shots against the most common forms of climate misinformation. Another resource that we've developed is I co-authored this with Daniel Bedford from Weber State University, and we basically wrote and published a textbook that uses the same approach and structure of misconception-based learning. And so each chapter looks at a key fact about climate change, and we start by having a very short summary of the key climate fact. Then we go into more detail about that climate fact. Then we introduce them to a myth that's related to that fact, and then we explain the techniques that the myth uses to distort the science. So it's that same technique as what we used in our massive open online course, but in a much more detailed textbook fashion. Now I'm actually at the end of my talk. I've got a couple of slides, and what I wanted to just tell you about was we're now developing a third resource for educators, developing a curriculum for high school that again uses this misconception-based learning approach. And what really inspired us to do this was a book that was sent out to educators a month or two ago to about 25,000 teachers, and what we decided to do was to use that book as an educational opportunity, use the misinformation in the book to teach climate science. So I got a copy of the book as well. I'm using it as my my coffee mug coaster on my desk next to my laptop. But I'm also using it as an educational opportunity and going through the misinformation, mapping the myths to the key themes in the next generation science standards and developing a curriculum for teachers to use. So we're developing a pilot study at the moment that we're hoping to implement probably in the first half of next year. And if any educators are interested in talking to me about it, finding more about it, I'd be happy to answer your questions, and you can contact me via this email address. So that's all that I wanted to say from my slides. It looks like the internet behaved itself for the last half of my talk, and I'd be happy to answer any questions in the time that we have left.
Thank you so much, John. I really appreciate you just sticking with everything, and I'd like to thank everyone who is on the line right now for their patience and sticking through this presentation from John. We do have some initial questions that have been put in, and for anyone who has any questions for Dr. Cook, please write them up now, and we have some time to go through some of them. And we have one question here that was presented early on, and it is, by misinformation, do you only mean information that minimizes climate change, or can you also refer to information that exaggerates climate change?
Yeah, that's a good question. Any misinformation is anything that distorts the science. And so, like on our website, Skeptical Science, we debunk examples that exaggerate the science as well. So exaggerating the risk from methane hydrates in the Arctic. I mean, that is a risk, but it often gets exaggerated, and the way it's exaggerated isn't representative of what the scientific evidence is telling us. Another example of exaggerating myths that we debunk on Skeptical Science is there's a documentary called Cowspiracy, which misrepresents the carbon cycle, and it argues that the CO2 emissions from the animal agriculture industry something like 52% of all greenhouse gas emissions. In actuality, it's about 15%. There's a number of reasons why that figure is wrong, and we explain how it went wrong and the ways that it distorts the science. So yes, I think that misinformation is anything that distorts the science. It just so happens that most of the cases in climate change it's downplaying the risks, or it's denying the reality of climate change, or downplaying the human role in climate change, and those myths are much more destructive.
I guess a follow-up, almost a direct follow-up from this. comes from another viewer who's asking how your analysis might change if it came from the other side. So can those who deny the seriousness of climate change inoculate the audience against climate change warnings?
So are you asking, is it possible to inoculate against climate science, like use inoculation for evil rather than for good?
Well, I don't want to, place good or evil, but yes, that's the question. Yes.
Yes, it is possible, and in fact, it's been going on for decades. And I think a good example of powerful messaging being used to misinform people is the fact that, like, our the experiments that I showed were about the 97% consensus, or the scientific consensus, on climate change, and just over the last half a decade or so, social scientists have kind of wised up to how important this is. But the importance of scientific consensus from the 90s, and they've been they conducted market research in the 1990s, finding that what the public think about consensus is really important. It influences their attitudes towards climate change in general, and consequently they've been putting into effect strategies and messaging and communication campaigns to misinform the public about consensus for decades, long before we even started measuring the consensus and communicating it to people. There's also research into inoculation, finding that it is possible to inoculate against inoculation. So I think that it's important that we do inoculate people, but it's not foolproof. It's not going to solve everything, and there will be attempts to try to undo the educational techniques that if we try to inoculate students against techniques that raise critical thinking, and we really need to and have to do that, that's not foolproof either. Those effects can be nullified by misinformation techniques as well. So nothing's foolproof, but we've just got to the worst thing to do is to do nothing. And so I think we have to engage in these education efforts and also continue to research in how to improve communication and education to be more effective.
So another one of our viewers is asking, so is this inoculation process just another version of producing cognitive dissonance to tell wrong facts to students that then improve their learning via emotional arousal?
It kind of, yeah, it is in a way. Now, one thing that first got my attention about this approach was I was actually at a climate communication workshop run by Susan Hassel, who's a wonderful trainer of climate communicators, and she talked about, she took a quote from the Made to Stick book. She said that sticky communication often creates a gap in people's understanding and then fills that gap. And I realized debunking really does that. Like, it creates a gap in people's mental model, and then you need to fill that gap with the replacement fact. And that really is about, that gap is that cognitive dissonance. It's creating that conflict, that unanswered question, and then answering the question. And the educational research into reputational teaching or misconception-based learning has found that students engage with that type of teaching more than standard teaching because you do have that conflict and that arousal. It's another reason why it's a powerful way to teach.
We sort of going back to our audience again. One of our one of our viewers is asking how important you feel it is to address skepticism versus enticing behavior change based on the audience's values. So whether or not they care more about air quality or saving money through energy saving, something of this nature.
I think that, yeah, I think that we need to do both. Firstly, misinformation is important because it lowers climate literacy, and that lowers support for various climate action and various climate policies. So that has a negative effect that reduces policy support. But there's many different paths to support for climate policy as well. So I think that we do need to explore other ways to improve support, like, you know, because you have different audiences, you have different bodies of students in different parts of the country, and so for some people, having values, I guess, talking about climate action through different values is effective. So yeah, I definitely wouldn't say it's one or the other. I wouldn't present that false dichotomy. I think that that we need to embrace both. And I think that sometimes I hear arguments about climate communication saying that let's just ignore misinformation and just concentrate on values or cultural framing. We ignore misinformation at our own peril, but also I don't think it should be just about debunking either or inoculation. We also need to be sensitive to the values of our audiences and communicate in ways that resonate with them. And often that is what the sticky science is, or the sticky message. It's finding ways to really resonate with particular people.
Thank you. I'm going to give you two questions back to back because I think you can sort of follow through with both of these. The first is whether or not you could readdress the earlier myth about the sun causing global warming. Apparently, it was recognized that your audio cut out a little bit as you were explaining some of this, and one person's asking her whether or not this was surely this was a logical fallacy, and wanting to get some guidance on some of the other issues that were brought up. And following on that, we have one person who's asking that, you know, in fact, climate science is some of the most complex material that they're aware of, and that they find it difficult to explain.
Hang on, Bruce. Could you rewind a little bit? Then the second question you cut out. Could you repeat the second question again?
Sorry, the first question was just going back to
the sun.
The sun, and just explaining that whether or not that was in fact a logical fallacy, as well as the other choices that were on that question. And then the sort of the second part of the question was that, you know, climate science being very complex material, and this person finding it difficult to explain the intricacies to non-scientists, which is a problem when you're trying to teach facts, and, you know, this person recognizing that the myths are much stickier. So if you have any advice about how to make the complex subject more accessible to an audience of non-scientists.
We're having bad luck because I got the first question, but both times the second question broke up. Let me at least answer the first question.
Sure.
And then maybe we can always go back to the second question. So, okay, now with the sun, I'm kind of in two minds about this. Now, from my perspective, the way I see the key technique that I think that the sun argument uses is cherry picking. Now, there is a documentary called The Great Global Warming Swindle. Came out a number of years ago, and their big argument is that the sun is causing warming. And to prove it was they show a graph of sun and temperature, and they show that the sun and temperature are moving lockstep, side by side, over the early to mid 20th century. And then in 1970, suddenly the temperature continues to go up, but the sun data stops. And so it's mysterious. Like, this was done in like around 2000 or so. Why did they suddenly stop the solar data in 1970? And the reason why is because around 1970, sun and climate start going in opposite directions. The sun starts going down and global temperature continues to go up. And so by cherry picking the data, they hide the fact that sun and climate are diverged and are going in opposite directions. So from that perspective, the sun argument is cherry picking. But I mean, to say that the technique is logical fallacies, there are a number of different logical fallacies. So I would be curious and interested to hear which logical fallacy that attendees think that the sun causes, and if it's possible to for them to enter it into the chat window. Is that possible, Bruce?
Sure. If attendees would like to enter this into their question box, I'll be sure to sort of parse it out and provide it all to Dr. Cook. So could you repeat?
While they're doing that, could you, I guess, give me a brief summary of the second question, and hopefully this time the internet will be good to us.
Yeah, I'll try and make it quick. It was climate change is a very complex subject and difficult to discuss the facts for non-scientists. The myths that are provided are relatively easy for non-scientists to digest. What recommendations do you have to make the facts of climate science a little bit easier to explain and hopefully a little bit stickier for non-scientist audiences, I'm guessing primarily students?
It's a really good question, and I kind of glossed over it during my talk, but science is complicated, and a myth can just be, because you're not bound by the truth, you can just make up something simple and easy and sticky, and it's a really unequal playing field. But the broad recommendation I give is look at those 6 traits of expected, concrete, credible, emotional, story. And I think that, like, if I was to give one tip, it would be concrete. Climate change is inherently abstract. Those 6 traits of stickiness, climate change is the opposite of all of them. It's a real challenge as a communicator. But there is one technique that is really powerful in taking complicated, abstract concepts and making it sticky and concrete for people, and that's analogies. If you can find an analogy that captures the science that you're trying to communicate, then firstly, you're piggybacking off existing concepts in people's minds, so you don't have to reinvent the wheel. And secondly, you're taking an abstract statistical concept and turning it into something concrete and real for people. And so, I mean, this is purely anecdotal, and I know that there's a whole body of research into the power of analogies as a communication device. But I know of 2 examples, one in my own experience where I was giving a talk to a group, and at the end I asked the people, did anyone change their mind? And one person said yes. And I asked, what was it that changed your mind? And she said, it was the analogy that I used to explain why North America had this really record cold winter. And the analogy I used was that because the jet stream had slowed, that was allowing all this cold air to come down from the Arctic. And it was like the fridge being left, the fridge door being left open, and all the cold is leaking out into the fridge, into the kitchen. And even though that analogy was didn't really have anything to do with explaining human-caused warming or explaining the basics of climate change and humans' role in it. It was an analogy that gave her that aha moment, that kind of moment of enlightenment, and it changed her mind about climate change. So I think that analogies can help people break through and understand concepts, and often that can be really powerful.
As a just a follow-up note, a while back we did a webinar on framing conversations of climate change, and for anyone who is interested to drop me an email, I will send you a link to the video archive and some of the resources that we put together for that presentation. So just as a side note for that. As we are running a little bit late on time, I'm just going to let everyone know that I have some closing announcements as well as some important information to provide to everyone who's come here today. If you still have questions that you'd like to ask Dr. Cook, please type them into your question box. I'll be assembling them and providing them to him. I know in his copious free time he'll hopefully have a chance to look at them and respond, and I will send those answers back en masse to everyone who's attended this evening. And with that, I'd just like to thank you, Dr. Cook, John, for taking the time out of your busy schedule and your evening to join us and to offer this presentation tonight.
Thanks very much for inviting me. I really enjoyed it, and my apologies for the internet.
Well, that does happen sometime. I certainly get it. And just some closing announcements for folks who may have joined us late, and just an important note at the end. Please go to your email. I have sent everyone a link to their post-webinar poll. If you could complete it right now when we're done, that would be terrific. And we're going to be taking July off, but we'll be back in August with our next webinar, Transitioning States and Countries to 100% Clean Renewable Energy for All Purposes. Finally, for those of you who came in late, we do have a number of summer professional development opportunities that are coming up in July and August. If you'd like more information on these in Connecticut, in Alaska, or in Maryland, please be sure to sign up to the NOAA Climate Stewards list today. The link is down here, and you'll get this in the video archive, all the information. These are all very low cost. If you can get there, they're pretty terrific opportunities. And in closing, I'd like to offer this much more involved moment of Zen image. And this is actually taken from the University of California, San Diego at Scripps Institution. And what we see here are, this is the Keeling curve. These are the carbon dioxide recordings from up at Mauna Loa in Hawaii. And this first one here shows going back thousands of years ago. So this is data before 1958. And what we see over here is that these are the data which is ranging back only to about 1700. Here we see the modern recording. Then we have it getting a little bit fuzzier, as you can see. This is for the data from the last 2 years, data from the last year. Then we have data just going back 6 months, data from the last 2 weeks, and then data from the last week. And this was just taken, actually, just a few days ago. And as you can see, we're up at 409.66 parts per million. And the reason that I've pulled this out is just to offer a resource to everyone that they can show their students prior to maybe talking about some of this misinformation by showing data that scientists are taking, how this data is variable over time, and trying to understand that variance as they look at it on different scales. Hopefully this will be of use to folks. As I said before, we'll be saving all of the questions for Dr. Cook. And I'm just really pleased that we had so many of you who were so thoughtful and stayed for the whole time despite our technical errors. And with that, I just like to say, hey, thanks for showing up. Thanks for being with us. Have a wonderful summertime in July, but we will be back here at the beginning of August with our next presentation. So thanks, everyone. Have a good evening. Bye-bye.